This one, we want to go to infinity. And basically, whenever we have x's in the power and x in the base, both the base and the power, we're always going to ln both sides. That's always how we deal with x's in the base and the power. So let's do this. Let's just bring it down. Let's take out um, the limit for just a minute. We'll just take this function, 8 over x to the 6x, and then we're going to ln both sides of ln y is ln to the 8 over x to the 6x, and then bring that power down. That's the great thing that that's the log quality we love that allows us to deal well with powers. Okay, so we get 6x times the ln of 8 over x, right? Okay, now we're taking, let's don't forget it's all about a limit, right? Limit as x goes to infinity. So let's just take this right side and take the limit. X goes to infinity of this. Now, if you plug in infinity right here and right here, not going to work out very well because you're going to get 6 times infinity times the ln of 8 over infinity. And what is that? 6 times infinity is infinity. And this is the ln of 0. You clear on that? 8 over infinity is 0. Anything, right? Because remember, infinity is like a million, a billion, a trillion. It's going to infinity. So if you have, you take a candy bar and you break it into a million little pieces, like dust. That's like give you 8 of the millionths of the candy bar, or 8 billions or trillions. That's basically nothing. You're getting to nothing, just dust, candy bar dust. So that's infinity times something that's basically 0. What is that? That's indeterminate. We cannot determine what that is. We don't know for sure because it can be different things. Why? Because it's basically 0. It's super close to 0. I should say it's infinity times something really close to 0. Um, oh, wait, hold on. That's not indeterminate. Hold everything. Ln is 0. I should say, let me get I'm just used to this. 0 from the right. That's basically negative infinity. That's very determinate. We can determine that. Let me hold the phone here for a minute. Yeah, why? Well, because let me show you a little graph of natural log. Here's y equals natural log of x. It's good to kind of know what that graph does. Natural log goes like this. He basically takes a dive as you get close to 0 here, as you get close to 0, down to negative infinity. So in other words, if you're walking along the x-axis if you're doing if this x, and if you're over here at like 3, and then you walk it back to 2, and you walk it back to 1, and then you're walking back and you're getting closer and closer to 0, where are you going? As x gets closer and closer to 0, the y value, natural log, goes down to negative infinity. That's why this is negative infinity. As you get close to 0 from the right. Why do I say 0 from the right? Because this is 8 over infinity is basically 0, but it is from the right. I mean, it's a positive number. Like 8 millionths of a candy bar is not negative amount of candy bar, right? It's positive number, very close to 0 from the right. So that goes negative infinity. So infinity times negative infinity, what's that? Well, negative infinity, right? So the limit, so as we take, so as I sneak in here, I'll just put the limit right here since I just did it. Limit as x goes to infinity. This is going to come out negative infinity because it ended up being infinity times infinity. There's nothing indeterminate or unclear about that. For sure, infinity times infinity is infinity. And then one of them is negative, so it's negative infinity. Now, careful, we're not done. It's still ln y on the left side. Now, how do we get rid of that ln? Whenever we have x is in the power and the base, we're always going to ln both sides. And in the last step, get rid of that ln to go back to the regular y, e both sides. So it's e to the negative infinity. Now, hold on. What is that, though? Well, that's 1 over e to the bottom. Remember, negative powers jump to the bottom. They don't mean negatives in the front. They mean, in the denominator. Okay, what's that? What is e? E is a special number, 2.718, blah, blah, blah. It's like pi is a special number, 3.14. So this is basically 2.7 to the infinity, which means, what does that mean? What's the infinity power mean? That means 2.7 times 2.7 times 2.7 infinite times. 1 over, that is. So that's 1 over infinity. right? Two times itself, 2.7 times itself, infinite times infinity. That's 1 over infinity. 1 over infinity is 0. Y is 0. The answer to this problem is 0. And so there we go.